Hello everyone, in this video I'm going to discuss the example for differentiation. Find the value of the first derivative for the function 2xy equals to cos x when x is equals to pi and y equals to negative 1 over 2 pi. So first what we have to do is to focus on the function. So here we have 2xy equals to cos x. So it means that we are going to make use of the product rule where we have differentiate the function uv, which is equals to v multiplied with the u prime plus u multiplied with the v prime. So let's begin. Differentiate 2xy. Kindly focus on y. Then differentiate the 2x plus 2x, differentiate the y where we have dy dx. Here we have the product rule. Continue. Differentiate the cos x where we have negative sine x. Differentiate the x and we will have 1. So kindly substitute the value when x is equals to pi, y equals to negative 1 over 2 pi. So in here we have 2 multiplied with the y, which is negative 1 over 2 pi, plus 2x dy dx equals to negative sine x where we have the pi, which is 180. So here we will have negative 1 over pi plus with 2 pi dy dx. By referring to the calculator where we have 0. Kindly rearrange the situation. So we will have 2 pi dy dx, 1 over pi. Finally, the value for dy dx, which is equals to 1 over 2 pi squared. Next, shows that when we have the function fx is differentiable at x equals to 2. My advice is to represent the piecewise function in the real number line. So here we have the function. On the left, 3x squared plus with the 12. On the right, we have 12x. Next, write down the formula where we have limits when x approaching a for the function fx minus fa over x minus a. So let's begin. Limits when x approaching 2, let's say from the left, for the function fx where we have 3x squared plus with the 12 minus we have f2. So refers to the real number line f2. When we are focusing on the 2, we are going to use of the function for the left hand side where we have bracket 3x squared, which is equals to 4 plus with the 12. So that is f2 over x minus 2. Kindly simplify the situation. So limit when x approaching 2 from the left, we have 3x squared plus with the 12 minus we have 24 over x minus 2. Repeat the same thing. Limit when x approaching 2 from the left, 3x squared minus 12 over x minus 2. So if we substitute the situation, and we will have 0 over 0, which is the IDF. So we have factorized, multiplied by the conjugate or long division. So in this part, my suggestion is to factorize the 3 first. So limit when x approaching 2 from the left, if we factor the 3, and we will have x squared minus 4 over x minus 2. Continue. Limits when x approaching 2 from the left, we have 3. Factor the x squared minus 4, we will have x minus 2 and x plus 2 over x minus 2. Limit when x approaching 2 from the left, if we simplify the common terms, so we will have the simplest form would be 3 multiplied with x plus 2. So finally, if we substitute the 2, and we will have the value of y, which is approaching 12. Next, focusing on the right hand side. Limits when x approaching 2 from the right refers to the function, which is 12x minus 24. So as we all know, the f2 will be equals to 24. Continue. Over x minus 2. If we substitute the value of 2, and we will obtain 0, 0, which is IDF. So suggestion will be factorize, conjugate, long division. Limit when x approaching 2 from the right. If we factor the 12, and we will have x minus 2. So kindly simplify the common terms, and we will have limit when x approaching 2 from the right, we have 12. So finally, the value of y approaching 12. So refers to the situation, limit when x approaching 2 from the left for the function fx minus 24 over x minus 2. On the right hand side, we have the limit when x approaching 2 from the right for the function fx minus 24 over x minus 2. And we notice that we have the value 12 for both sides. So we can say the limit is the same. So limit when x approaching 2 for the function fx minus 24 over x minus 2, which is approaching 12. Or we can say the limit exists. So from here, we can say f prime 2, which is equals to 12, and exists. And we can say finally, function of fx is differentiable at x is equals to 2. Thank you so much for watching this video. If you think the video is useful, kindly consider to like, comment, share and subscribe.